Hey everybody, this is Mr. Warner. We're going over 3.4, building polynomials from roots. So we're going to do a quick review, solving these little equations. Okay, so if we're trying to solve this equation, we want to get x by itself, we'd have to subtract 5. Why subtract 5? Because it's a plus 5, we want to do its opposite, right? Its inverse. Okay, so we'd end up getting x equals 5, negative 5. Okay, for b, very similar. We just want to add 1 to both sides. So we'd get x equals 1. And then for 3, same thing. It's a two-step. We'd have to add 1 to both sides. So we get 3x equals 1. And then we'd just want to divide both sides by 3. So you've done this a lot of time when we've been trying to find our roots. Like if I gave you a factor of 3x minus 1, and we wanted to find the 0, we would set that up, and we would solve, okay? So that is that, and then we have problems that look like this. I think we did problems like this when we were doing 3.2, when our solutions maybe weren't factorable. We couldn't factor the quadratic, and so we had to solve one of these types of problems. So again, we'd want to get x by itself, so we could subtract both sides by 4. So x squared is equal to negative 4. And then to get x by itself, we would square root both sides. Again, just a reminder, when we square root both sides, we end up getting plus or minus. So we'll get x equals plus or minus. Again, the square root of a negative is an I, and the square root of 4 is 2. So we would get 2i. And those would be our two solutions. Okay? Here's another example. We would add 7. So here we have a positive number that we're going to square root, so we're not going to have an imaginary, but we still will want to square root, and it gives us irrational number, right? So this would be plus or minus. So we'd have like square root of 7 and negative square root of 7. All right, and then f, I'll leave that one to you. This would be like a quadratic formula type of problem. There's nothing that multiplies to 10 and adds to negative 4, so you would have to use the quadratic formula. All right, so why do some of the problems that we just did end up with a plus or minus? When does that happen? So it happens whenever we have to square root. So when we square root, that gives us that plus or minus. Okay? So a little hint is today we're going to be kind of going the opposite direction. I'm going to be giving you the roots, and you're going to need to write down the equation. So we're going to basically go the opposite direction. If you ever had to use square roots to solve, then we're going to need to do its opposite. We're going to have to square both sides. Okay? So one thing to notice is that when you're solving a quadratic, it's impossible to get the square root of 2 and not get negative square root of 2. So these always come in pairs. When we have those plus or minuses, like when we square roots, we always end up getting a plus and a minus. So that's called, oh, now the word's missing out of my, I can't remember. It'll come to me. Give me a sec. Anyways, I think I have it over here. Yeah. Conjugate pairs, that's the word, right? So conjugate pairs. Conjugate pairs are the same. They just have a plus and a minus, right? Okay. Anyways, you'll end up needing to do this as well, but just to save some time, we'll go to the actual problems, okay? So 3.4, here's our notes, and I'm going to give you the solutions, the roots, and I want you to write down the equations, okay? So you probably wouldn't need to do this every time, but I'm just going to start by just doing the opposite of what we did above. So here we would want to subtract 2 to both sides, and we'd end up getting x minus 2 equals 0. So that would be one of our factors, and we'd do the same for the other, and we would get x plus 6 is equal to 0. And then to write our equation, we're just going to put those factors together. So we'll end up getting x minus 2 and x plus 6. So if your roots are just rational numbers, you can pretty much just go straight from here to here, okay? But I'm just trying to keep that in mind, that we're just kind of going the opposite of what we did just above, okay? So this is factored form. We're also going to be asked sometimes to write our answers in standard form. So again, to go from factored to standard, we want to distribute. Okay, so when we distribute, again, oftentimes we would use a box. There are other ways to do this, but we'll just stick with that here. And we'd multiply and combine like terms. So we'd end up getting f of x, our function, is equal to x squared plus 4x minus 12. So that would be standard. And this is factored. Okay, let's try another one, maybe a little quicker this time. So we've got our roots, so we could probably just go straight and write our factors. Okay, I'm just going to do this red so it matches. Okay, so one of our factors would be like x minus 0. So we could just write x, and then our other one would be x minus 5 times x minus 5, but we could just write that as x minus 5 squared. So this would be more like what you would see on the problems we've done in the past. Okay, so if we want to put that into standard form, now we have three factors, right? We've got an x, and we've got two x minus 5s, and we'd want to distribute all of those. So how you want to do that is up to you. The order that you distribute is up to you. I'm going to start by, I'm going to rewrite this out here so I have a little more space. Okay, I'm going to just distribute the x, so I would get x squared minus 5x, and then I'll be multiplying it still by that x minus 5. So now maybe I would use my box. I'd have x squared minus 5x times x minus 5, and I'd get x cubed negative 5x squared negative 5x squared and 25x. Combine like terms, I'd end up getting f of x equals x cubed. We'll combine those, will give us negative 10x squared plus 25. Okay, last one with rational numbers. Again, we would want to write that out. Again, each of those will give us our factors. We'd get f of x equals x plus 2, x plus 3, and x minus 3. So if you want to distribute to get to standard form, again, you're going to do a group at a time. So again, you can choose this. If we multiply these two first, it'll make it a little easier. But I'm just going to do an example where we end up having a binomial times a trinomial. So I'm going to do my first box. And you won't have to do this very often, but would have x plus 2 and x plus 3. So we get x squared, 2x, 3x, and 6. So we'd end up getting x squared plus 5x plus 6, and we want to multiply that by x minus 3. So again, if we're going to use the box, we'd end up having a 3 by 2 box. So I'll get x cubed, 5x squared, 6x, negative 3x squared, negative 15x, and negative 18. Combine like terms. If I didn't mess anything up. So we end up getting x cubed, I think I'm okay, plus 2x squared, and we combine those two, and then when we combine those, we'd end up getting minus 9x minus 18. So that would be our equation in standard form. All right. Okay, so I think most of the ones on your homework, at least when they have nice numbers, they'll probably be like factored form. There will be a couple when we end up having standard form. So like here would be an example of where we have an irrational number. So it's not, our factor isn't x minus the square root of 5. To have something, or I guess that is a factor, but when we write a polynomial, we want to have all of our numbers be like integers. So maybe no fractions, no irrational numbers, no imaginary numbers. Okay, so again, we're going to kind of go the opposite direction. If you ever see a square root, we're going to want to get rid of it. So we would square both sides. We'd get x squared equals 5, and then we'd want to subtract 5 over to the opposite side. So x squared minus 5 is equal to 0, so that would be our equation. We'd get f of x equals x squared minus 5. And this is in standard form. So you will always be writing your answers in standard form if we ever have like irrational, like a square root, or an imaginary. Okay? So here's another example. This will just skip this. If you want to see the notes for that, that's great. If not, don't worry about it. This won't be on the homework or the test, but something like this sure could. So again, same sort of thing. How do we end up getting an I? Well, that's when we have the square root of a negative.
Attention Westlake staff. We are testing the intercom. Thank you for your understanding.
Sorry about that. Okay, so we end up getting an I if we are doing the square root, because I is the square root of a negative 1. Okay, so if we want to undo that, since we square rooted, we're going to want to square. So we're going to square both sides. Would get x squared equals, and then we just have to remember what happens when you square an I. So here's like an example that we did right here. What happens if you square a square root? Well, those are their opposites. They cancel out. So I squared is a negative 1. So here we would end up getting 2 squared, which is 4, times I squared, which is negative 1. So we'd have x squared equals negative 4. And you could probably just skip that step. Just remember that when we're squaring an I, it's going to change the sign. Okay? And then the last thing we'd want to do is to add 4 to both sides. And we'd get x squared plus 4. And that is our function. Okay? Again, if you were to set that equal to 0 and solve, you'd end up getting plus or minus 2i. So when we compare that, it's not the same. I'm giving you one of the roots, but again, imaginary roots and irrational roots, like a square root of 7, they always come in conjugate pairs. So just again with that. So if you have anything that's like a square root, and I think this should say irrational. Irrational or complex, okay? You'll always have pairs of those. And for the examples that we've done, A is just 0. Okay? So, anyways, okay, let's do one more example. So here we have I, one of our roots is negative 7I. And if we have an I, how we got that is by square rooting. So we want to do its opposite. We will square both sides. So x squared equals, and then the square, or when we do negative 7 squared, that's 49. And then the square root of I is a negative. So then we'll add 49 to both sides. Sometimes people forget this step. Okay, so be careful with that. Would end up getting x squared plus 49. And that is our function. Okay, so 8, same sort of thing. We'll just skip that. If you want to go over that with me, feel free to come by, okay? All right, so these first two, they both ask you to write down your polynomial in factored form. So these are pretty quickly. We don't need to switch it to standard form. This would be f of x equals x minus 2, x minus 3, and x plus 4. And that's it. For 11, this one's a little different. It tells you a multiplicity. So here we would do f of x is x plus 1, and then x minus 2 with a multiplicity of 3. So again, multiplicity, we're going to have an exponent of 3. We could write that out 3 times. We'd have 3 roots of 2. All right. Where it says like degree 3 and degree 4, it just means like when we're done, we should have a degree of 3. And that makes sense, right? We have x, 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 so that's x to the 3rd. And then for this one, we've got x and x cubed. That gives us the 4. Okay, so you can always kind of check for that, make sure we're not missing anything. Okay, and then the last two, let's look at these really quick. We want to find the roots. Actually, let's start with 13. Okay, so we have a degree of 3, so we should have 3 roots. But again, here we only see 2. But remember that we always come, like the imaginaries or the irrationals always come in pairs. So there's also a negative 2i. But the way we solve these problems, we don't have to worry about it. So we just set each of these equal to x, so 3 and x equals 2i. And then we are wanting to write down the factors. So for the left side, we would just need to subtract 3, and we would get x minus 3 is equal to 0 is one of our factors. And we'll do the same for the x equals 2i. So again, if you have an I, that means it was a square root of a negative. So we'll need to do its opposite. We'll want to square. So we get x squared equals negative 4i. Again, 2 squared is 4, and I squared is a negative. And then we'll just need, oops, sorry, there shouldn't be an I there. And then we'll just add 4 to both sides. So our other factor would be x squared plus 4. And then to put it into standard form, which is what it's asked us to find, is we would want to distribute, use the box. So I'm going to draw a little box. We'd do x minus 3 and x squared plus 4, and we'll multiply. So we'll get x cubed, negative 3x squared, 4x, and negative 12. So f of x is equal to x cubed, make sure you put in standard form, minus 3x squared plus 4x minus 12. Okay. All right, and then we'll finish this last one. Same thing, would end up getting x minus 5 as one of our factors. And then here I'm just going to set it equal to, oops, that was not great. X equals to the square root of 3, so we'd square both sides. X squared equals 3, and then we would subtract, so that would be our other factor. Okay, and then we'll multiply, so it's very similar. Nothing really different at this point. X squared minus 3, so we'd get x cubed, negative 5x squared, negative 3x, and a positive 15. So f of x is equal to x cubed minus 5x squared, minus 3x plus 15. Okay, so I think these are a lot like 10 and 11 are kind of like ones that you'll see on the test and perhaps the your homework. And then same as 12 or 13. You'll see a lot of that on the homework too. All right, we'll see you later.